Hey, this is Brock Lemire's, and in this video, we're going to look at file input and then talk about what file I/O can look like with binary files. Okay, so we looked at how we have the standard I/O header file that has fprintf and fscanf, and fscanf is good. There's a few items to consider. This is when you read from a file. Whenever you read from any file, you have to know the format of the file beforehand. It's really tough to write scripts that try to like determine what a file format is. So almost all the time when you're messing around with your own files or files that are pre-made, you know the format. You know, are they comma delimited? Are they, just columns of information? Is it text? Is it binary? Whatever. The other thing you need to watch for is when you read from a file, you need to watch for when you reach the end of the file, because you can think about like scanning through a file as you'll open it up and you read it in line by line. And then at some point when you get to the end of the file, there's nothing left to read, and so you'll error out. So these functions that read from files, they actually have built-in kind of end of file functionality. Fscan particularly will actually return a negative number when it reaches the end of the file. And then the standard IO header provides a macro called EOF, which stands for end of file. But all it is basically a label. It's almost like a pound defined that makes it easy to read when you code up, that you could basically say this: while fscan of whatever is not equal to end of file, then keep going. So this could be when it's not with just a negative number. You could do like a less than or whatever, but this is a common syntax. Okay. It's also nice to check to make sure that the file actually exists. Okay, so let's do it. So let's go into mod 11 code along. And what we're going to do is we actually need a file to read. So down here, what I'm going to do is I'm going to create, let me go into mod 11 code along and take a look. I got all my files in here. I'm going to create an input file. So I'm going to go vim input file.txt. And I'm basically just going to write some, the month, 3 letters, and then a number. Okay, so this will take 2 seconds. 995, and then March, we won't do them all. 887, let's do at least 6 of them. So April 783, and then May 784, and then June, June 800. Okay, so let's write that, and there's no, so there it is. So now let's look at it, and it's like we got this input file.txt, and that's what we're gonna open and look at. Okay, and we'll start with scanf. So let's go vim file in.c, and here we are. So we're going to start with the comment header. So file in, and then we'll go like that. And then we're going to go pound include standard io.h, which has the fscanf function. And then we're going to build our main function. So int main void open curly, come on down, return 0, and close a curly. Save it up, come on back up. And now let's do our file commands. We are going to use the syntax capital F-I-L-E to say, I would like to create a pointer that will point to the beginning of a file. So this is a pointer, absolutely, but it is a unique pointer. It's not going to point to ints. It's not going to point to doubles. It's pointing to a file that will be in non-volatile memory. Okay. Now, let's create a couple buffers just to read lines into. So I'm going to make a string buffer. I'll call it buff1, and let's make it kind of big just so we can read stuff into it. And then let's do another int, which will be buff2, and then we'll read information into there. Okay, so here we go. I'm going to now open the file and initialize my file pointer. So I'm going to do the following. I'm going to say fn equals, and I do the command fopen, and now what I'm going to do is I'm going to give it the name of the file, input underscore file.txt. I know this exists, so we're going to do one where the thing exists and you don't error out. And then I do it in read mode. Okay, now watch this. I'm going to use this syntax that says, you know what I want to do? I just want to read everything in using scanf, okay? And then I'm just going to print it right out. Okay, so let's think about why we did a char buffer and an int buffer. I'm going to use scanf and use format specifiers to basically, remember scanf separates everything by space. So scanf, what I can do is I can put %s right here, and then %d right here, and then a space between them. And it'll be like, okay, put this into the string, put this into the integer. Okay, so watch this. Let me do the fscanf syntax first so it makes sense. Fscanf, and what I'm going to do is I'm going to go to the file in, which is my file pointer. And what I want to do is I'm going to do this. I'm going to go read the file in as a string, then a space, then a D. Okay. Now you're like, how does it know when the string ends? Well, the string ends whenever scanf sees a space. So it does automatically kind of space delimit this. And then all I do is I say buff1, and I want you to think about this. We've come a long way here. Buff1 is the name of an array. It is also a pointer. It is the address of the first location in this array. I just simply put buff1 because it is talking about a string. Now come with me on this little journey. I am going to do buff2 to read in the number. I have to put ampersand to say address of, because buff2 is a reference to a scalar. It is not a pointer. So I have to actually use the ampersand on anyone that's not already a pointer. Okay. All right. So let me save this up. So that's the syntax for the fscan. Now I'm going to embed this within a while loop. So I'm going to do this. I'm going to go while, and I'm essentially going to do the following. I'm going to say while this is not equal to end of file. So not equal, and then fscanf, and that function right there will, if it returns negative, then we'll jump out and be done. Okay. So, and all I got to do is do that. Let me get to the end there. So I'm going to go pop, pop. That closes my while loop. Okay. Well, I mean, sort of here. I just need more room. I just need more room. So here's the thing. Here's the buff2, and then I do that, and now I got curlies I got to open. So I'm going to open my curly, I'm going to close my curly, and then here come over here, and I'm going to do this. I'm going to say this. I'm going to go printf, and I'm going to print this to the screen now. And I'm going to go ahead and print %s, that's the string part of it, space, %d, that's the integer part of it, and then a line return. And then I'll go ahead, and this time I can just put buff1, buff2, and life is good. Okay, so let's see what happens when I do that. The output should be like this, but I'm going to cover that up so we only see our own. All right, so let's go ls, let's do clear. Now let's do this, gcc, and this is going to be file in.c. And I'm going to direct the output to the executable to another file. Oh my goodness, I don't know what that was. I'm going to go clear. Okay, here we go. GCC file in.c, direct the output to another file called file in. Take an ls. All right, there it is. There's my file. So now what I'm going to do is go file in and run it. And lo and behold, it read what I typed in that file and it printed it out. So we were able to open the file. We were able to read it in, make sure that you didn't hit the end of the file. And then if you did hit the end of the file, you jump out of the while loop and return out of the program. And we were able to parse it into little chunks and save it. Now, you're sitting here going, holy cow, you forgot to close the file. And you're right. I did not close that file because I'm a bad programmer. So now let's go ahead and try to, hopefully the operating system hooked me up. Okay, that's pretty good. I mean, that's pretty good. One thing to do is see if the file actually exists. So when you do the fopen, like when you come up here, you can actually check to see if it exists by comparing it to the null. So here's an example. I can take this entire thing and now I'm going to check whether it exists. So I'm going to do this. I'm going to say if, and then I'm going to open this up and I'm actually going to put this entire thing in parentheses. Okay. And then I'm going to do this. I'm going to say, if that equals null, we got some problems. Okay, so I'm going to do this. I'm going to come over here and I'm going to say open curly, and I'm going to say printf. Oh boy, printf air opening file. Okay, and then I'll say exiting, and then I'll do a line return. And then I'm going to use a nice new command called exit1, and that means jump out of this program ASAP. Okay, so it's not an error. What it's complaining about is this whole exit and null thing. That's actually out of the standard lib library. So I got to actually pound include the standard lib.h library. You almost kind of always use standard IO, standard lib, math, and string, but don't do it. All right, so here we go. So I'm going to run this and make sure it still works. So I GCC this, and let's see, does it still work? It still works. Now let's do this. I'm going to change the name of the file. So let me clear this and look at what's in here. I'm going to move this file, input file.txt to input.txt. Okay, so I don't have it anymore. So now the file doesn't exist. So this error checking situation right here can actually check that and say, hey, this file ain't here. So let me compile that and let me read this. Let me run it. It's like, hey man, I don't see this file. I'm out of here. Okay, so let's move this back. Input a thing to input file.txt because we kind of want that thing. So let's make sure that it works, clear it up, GCC little buddy, and then run the little buddy. Oh, baby. Okay, so we're back. All right, life is good. Life is good. All right. Now, what if we want to break up a line? Maybe we want to say, hey, fscanf has some vulnerability. Why don't we bring everything in as a string so that we can bound how much can come in on a line? So let's use fgets. Okay. Turns out fgets also can read from a string, or excuse me, from a file. It's just that instead of, remember how we had to put standard in on fgets? In this situation, standard in was the keyboard. In this situation, if we just put the file pointer, it will read from that. So let's do the same thing here. So I'm going to come up here. And I'm not going to use scanf anymore. I'm going to use fgets. So I'm still going to have my fopen error checking here. That's not what we're worried about. That just checks if the file exists. I'm going to use fgets though. So let me do this. I'm going to go, I want to get this up here so you can see this. I'm going to comment this out so that we don't open it twice. And then what I'm going to do is I'm going to come down here and I'm going to do an fgets. All right. So here's what we're going to do. First of all, let me show you the syntax for fgets. I'm going to go fgets, and I'm going to put this into buff1. Okay, and you might remember it's like what's buff1? Buff1 was our big character array, so it's a string, and it's big. I made it big enough so it could take everything, right? But now what I'm going to do is I'm going to put everything into buff1. I'm not even going to mess around with buff2, which was the integer, and I'm going to bound how much information can come in. I'm going to say only 50 characters, please. And then I'm going to say read it from fn, which is my file pointer, okay? Now, the way that fgets can do end of file checking is that if it's equal to null, it will say that it's at the end of the file. Okay, so it's like, man. So what I do here is, as long as it's not equal to null, I can then put that entire thing in a while statement. Okay, so I come over here and I go while. Now you're looking at this and it's just two different ways to do the same thing. So this is how you do end of file checking for fscanf. This is how you do end of file checking for fgets. Okay. All right, so I'm going to do that. All right, so I got that little fella. Now let's go ahead and open that up. And let's just print the thing out, okay? Notice that fgets brings everything in as a string. So there is nothing else to print. It's not like I put buff2 or anything like that. It's all a string. And there we go. Okay, so now let's see if fgets can do the same functionality. So I GCC it. I run it, and lo and behold, it is. So I got the same functionality with fgets, but now I have this safety feature that I'm limiting how much per line can come in, okay? Well, now the issue is fgets brings everything in as a string. How do you split them apart? Because if you look at this, if you look at like what the actual information is, this is one continuous string. It's not characters and then numbers like it was with fscanf. So we have to split it apart. So it turns out that you can use a function called strtok in the the string.h library. And what strtok does is you feed it a string, a pointer to a string. And then what you do is you give it what's called a delimiter. So in our case, our delimiter would be a space. And a delimiter is basically how it's going to break things up. Okay, so what it'll do is it'll say, go ahead and look at the string, and whenever you see a space, go ahead and everything you've read till then, go ahead and call that a token and return it. Okay, and so for example, if I did strtok on buff1 and then I give it a space as a delimiter, it would return the first line. Okay, so that's where to split it. So a little extra step, but this is actually probably more common to do it this way than with fscanf. But I do need the string.h library. Luckily, we did a whole module on that. So string.h. Luckily, we did a module on everything. I mean, it's almost like you're learning the C programming language. It's remarkable. Okay, so here we go. So I'm going to bring this whole thing in, and now what I want to do is I got it in a string called buff1. I need to token this thing apart. Okay, so here's what I'm going to do. So I got while fgets, all that sort of stuff. What I'm going to do now is I'm going to use this token thing. So I gotta create a token. So I'm going to go car, and then I'm going to do a pointer token. Okay. Now you're looking at that going, whoa, 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 what did I just do, man? You just defined a pointer to the beginning of an array. Whoo! All right. Where's those square brackets? That's all right. So now what I'm going to do is I'm going to say assign to my token string tok, and I'm going to go buff1 into sections. And as soon as you see a space, go ahead and just return it. Okay, so I go ahead and do that. And I've now delimited the thing. And now what I'm going to do is instead of printing all of buff1, what I want to do is I want to print token. Okay, so I'm going to come in here and go ahead and print token. Okay, it's like, all right, whatever. So we're going to come in here, we're going to go GCC, run it. Look at this. This is interesting. Yeah. It's all gobbled together. It's because I didn't put a line return in here. Let me put a line return in here. So let's put a new line, and now let's see what I get. So I come in here, and I want to get my, boy, what a mess. Let me clear this and do GCC, and I'll run it, and I got it. Okay, that's kind of interesting. Where's the year, or where's the number? Well, it turns out strtok just grabs the first one and gives it to you. And the rest of it is knotted there. You're like, well, what happened to the rest of it? It turns out it doesn't actually get rid of the rest of it. What strtok does, it's really interesting. It actually goes through the line, and when it sees the delimiter space, it replaces it with null. So that's how it's like, okay, so I'm going to return this to you as a string, and null will be on there. And I actually physically put null in here. So it actually goes through and puts null in these blank spaces. You're like, okay, why did you do that? Well, it turns out that you can do back-to-back strtokes. And if you then start at null, you can go get the next value. So look at this syntax right here. Here's what we're going to do. This is odd the first time you see it, but I do a strtok and I put the information into token, but it's the first. So it starts at buff1. That is the first. It's basically a string holding the entire line, and you start at the beginning and you go till you see a space, grab it, return it to token, and then go ahead to buff1 and put null where you found the first space. Now watch this. I'm going to do another token, and I'm going to do this. I'm going to go string tok. Don't start at buff1, start at null. And as long as you do this right after the first strtok, it'll still operate on that string. And then go, okay, how about this one? So now let's do a space there. And it's like, okay, all right, whatever. Now it's going to print the token. Let's see what it prints this time. So now I go GCC and I do a file in. Oh man, look at this thing. Now it printed the number I had. Isn't that interesting? Look what else it did. So this time, this token, I overwrite what was in token with now the second value, the second column information. You want to know what's nuts about this? Look at, there's an extra return in here. That's because fgets grabs the whole line, including the line return. So that's why you have that line return issue with fgets. And if you want to strip that off, you basically do that whole replacement thing. For what we're doing today, you could basically come in here and do, if I want to strip it off, let's just do it. So I'm gonna go. No, I'm not gonna do it. Just run out of time here. Okay, so basically we're done. Okay, so for this one, if I wanted to make this clean, I'd be like, you know what? Just do that. Don't use your explicit line return. Just do that and use the one that fgets brought in. Okay. All right. So that's file input. Now you also have the ability to read and write files in binary format. A lot of times with the overhead of converting stuff to readable text, such as ASCII, is very heavy. If you're like doing a lot of just raw data processing, you don't want to store it as ASCII because ASCII has all this extra stuff in there, line returns and spaces and tabs and all this stuff that it's not important to the data. So you can absolutely read and write files that are just raw binary. You can't open them with anything other than your own program or like a binary text editor. But what you have is the ability to open it in two binary modes using fopen. So you do the exact same thing. It's just that you put a B after the W and the R. This will create a file to write to in binary, and this will create a file to read from in binary. And then instead of using fprintf and fscanf and fgets, what you do is you use these files, these commands fwrite and fread. And it's all the exact same thing. It's just that you use these different commands. And then there's one more piece here where you actually will specify when you do the write and the read how wide the data is going to be, because you're like banging bytes now. I mean, you're going to write bytes of data, and you're like, you have to actually tell it how many bytes you're going to write. Okay. That is it. That is file IO in binary and also file input with text. All right. Nice work.